then you've got a little bit more complexity. So things can get kind of tricky. So I'd say overall the trade-off is you lose a little bit of customizability, but man, you can get like a LaTeX document in 5 minutes that looks pretty good. So that's a big win sometimes. And so Markdown specifically is a shortened version of HTML. How familiar are you guys with Markdown in this room? But yeah, everyone's heard of it? Anyone not heard of it? Anyone like tried to use it? Who's tried to use it before for like a blog post or something like that? Okay. And it's pretty ubiquitous now. It makes like writing for the web a lot easier. It's just totally standard stuff for bloggers and web designers. And cool thing is now with stuff like Pandoc, we can kind of adapt it to our scientific needs. So we can use it to write scientific papers and stuff like that to some extent, which is pretty fun because then we benefit from a lot of the efficiencies of having this really lightweight language that can convert to like lots of different things. And basically, if you're familiar with HTML, there's these like tags you have to do. You have to do like, open parentheses B to get like a bold character and all this stuff. You have to do like href equals to do a link, image src equals. All that stuff is just kind of like wordy and unnecessary. So Markdown basically just gives you these simple characters, like asterisks and stuff that will convert to those HTML tags for you, so you can write a lot faster. It's what's in like Reddit comments is a lot of like comment boxes all over the internet, so it's become pretty standard. So I already went into the value proposition stuff a bit. Let's get started with like Markdown and how I would use Markdown. So what I've got here is Dillinger, an online Markdown converter. There's another one called Markdown Dingus. I like Dillinger because it's got a little bit of a nicer style to it. So on the left here is the Markdown that I've written, and on the right is the HTML that I converted to. And of course, that's the same thing that basically got published when we pushed this thing to the GitHub page that is the UofT Coders website. So let's take a look at this. So with Markdown, something looks like this. You can use these hashtags to indicate titles. So here I've got like the mega title, the subtitle 1, and the subtitle 2 here, with just some really BS pseudoscientific text. And essentially, well, this is what I've done here. So title 1, subtitle 2, subtitle 3, some body text, separated naturally by like, just the space, no like p tags or anything like that. And here it is rendered into HTML. Now, if you were to look at the HTML output of this, there would be all those p tags and h1, h2 tags and stuff. So it generated that easily for us. And I've also gone through and did a little handout. Oh no, yeah, how do we get that? Probably here. Cool. And I did a little happy thing here, and I just took a screenshot and pasted this image here. But so this same little text here that I wrote, converts into Markdown on the website, and with the Pandoc, convert the HTML command to this. But with the Pandoc to LaTeX command, then we'll get something like this to pop up. And if we want to take a step further, and we wanted to do some of the cool stuff that LaTeX makes really easy, compared to like Word and stuff, which is kind of like headers and page numbers and some of those things that are important in long documents. That's not too tricky, and then we can get some output from essentially the same input text that looks like this, with a nice little subheading numbered section shit going on. So how would we do this? First, you got to install Pandoc. You got to install LaTeX, which is more complicated than it should be. There's all kinds of different distributions and stuff, and depends on your operating system. You had trouble, you said, installing like LaTeX and getting something working? Or was that Pandoc? Yeah, you were being in class. No. Sweater. Me? Yeah. No, I was good. It was good? Okay.
I landed something else.
Okay.
And solve the moment.
Oh, yeah, okay. That's usually the way to do it. Yeah, I mean, yeah. my first LaTeX experience was on like Windows with like,
No, LaTeX got installed in a while, because that all software inside of my entire thesis.
Cool. So once we've got Pandoc and LaTeX installed, then we can start to do the stuff that we want to do. I put in this little question mark install xetech thing because that's like a specific engine of LaTeX conversion from Pandoc or LaTeX generation that's necessary for some of the stuff that I've worked with in the past. And I'm pretty sure it's installed automatically with Tech Live, which I suggest that you guys install, but I'm not exactly sure if you did that Windows or that Mac Tech thing. I'm not sure if it's in there. Anyway, so let's go back to the Dillinger and really quickly go over the basic Markdown stuff. It's not too complicated. It's always there on like Daring Fireball. If you want to like look at the little syntax things, what in Markdown converts to what in HTML. But it's really powerful if you can like remember these things, and then you can just write and it flows, and it's actually fast and kind of fun. So just a little crash course here. We got Markdown, little title, italics, with 1 asterisk, bold with 2 asterisks, that happens to be 3 asterisks. You get a bold italic, that's cool. Sweet. Lists are super easy. You just do, some kind of list character and then space over, and then you can build lists like that. You can even do, there's some flexibility, so you can do multiple different types of list characters. You do those dashes that I use, you can also use asterisks themselves. And it all works. That's nice, but if we have 2 asterisk list elements followed by 2 dash list elements, it separates them a little bit. So it's kind of smart. It knows that they might belong to different lists. Of course, you can do numbered list too, just with 1 dot, 2 dot, 3 dot. And I'd say the most important things to memorize and do fast are just links and images. So here's what a link looks like. You put in the text you want to display in the square brackets followed by the URL that you want the text to link to in these circular brackets. I always think it's the opposite for some reason. It makes sense that square brackets are for the more codey thing, but that's not how it is. So just always try to remember that, I don't know, what's being shown is in the square brackets. Images are maybe a little more complicated, only because they have a exclamation mark or a bang in front of them, but then it's pretty much the exact same thing. You do a bang, and you've got square brackets. That's not so important what's in square brackets anymore because this is an image. That's going to be your alt text. Of course, which is when you hover over an image on the HTML page. And then that circular bracket area back there, that's the path to your image. And of course, you got to make sure those are well formatted, you have the right file path, and don't put quotes around it or it doesn't work. For sure. And also what's really cool for doing stuff like the study group does is you can do code in line with your documents. So if you want to do code in a sentence, just follow it up and preface it with backticks. Now these aren't just like apostrophes, these are backticks up there in the far left, northwest hand of your keyboard. One of my favorite things is doing these code blocks, which you can see here. 3 backticks, space, something you write, and then followed by another 3 backticks will make everything between those like 3 backtick lines code. And the coolest thing is that you can also indicate syntax highlighting for what kind of code that is you're writing. And if it's supported by the browser, which it usually is, then it will make it look all professional. So JavaScript here, we can change it to Java, and it will look a little different. If we give it SQL, then it really won't know what to do. Let's see. But that's a JavaScript statement, so it's like this. Sweet, and those are basically the backbone of it. There's a little bit more advanced Markdown stuff, but that is like essentially it. The bread and butter is just images, links, and then bolds, italics, and headings. And That basically forms the backbone of the internet. Now let's go to Pandoc. That's good. Okay, so I'm gonna leave that lesson. Maybe you guys have that up. There's some like links there on that lesson. Make sure that that's useful. We're going to go to cool. So now I'm going to go to my terminal. And if you guys want to follow along, open up your own terminals in some directory. So first I've got a sample markdown file right here that I wrote. And it's just super simple. But I've got a little image tag in there, so it's kind of cool. So just write something like that, say the sample.md, sample.mdown also works. If I'm in the same working directory as that file, I've got Pandoc installed. Turning that thing into an HTML file is as simple as Pandoc, name of that file, then -o, and then name of the output file. That's my favorite way to do it. And just change the file extension of the output to be the file type that you want. You can explicitly define it, but it's smart and it will understand this for you.
Can you see that again?
Oh yeah, sure. Let's go back. Yeah, so basic formula that I follow is Pandoc. Then you give it the file you want to convert, and you do -o, which means basically -output, and then name of the file you want out, followed by the file extension that you want that file to have. And with just the default Pandoc installation, it'll work for .doc, .pdf, .text, .html. So I've made this HTML file, and it will open up my browser, and now it's got the title and the subtitle is just plain HTML. But look, my image is working, which is kind of cool.
Sorry, you said it was .doc?
Yeah.
So I tried that and it just gave me a bunch of, it gave me the underlying HTML code, actually.
Huh.
So let's see if I'm here.
Yeah, okay. So here's the doc file. Probably.
Right? Wow.
Yeah.
Okay, whatever.
What does the error say? Does it say anything?
There's no error.
Huh. Okay, one thing you might want to try is the next step, which is -s. Is one of the other really important command line arguments to give to Pandoc.
Oh.
So output .o is output, is how you find what the file type you want to convert. But -s will indicate that the file that you produce should be standalone. The typical behavior of Pandoc is basically just to go through and give it as markdown markup to convert that straight over to HTML or to text, but it won't actually build the whole file that you need to display those things.
That worked.
Yeah?
Yes.
Okay, interesting. Yeah, so tech is the biggest example. If you just try to convert straight to LaTeX, it'll make some LaTeX, but a whole LaTeX document has all this boilerplate, this head and document type and stuff. So you need to give Pandoc that .s command in order to get that. Okay, so I'll try with this sample, and that looks the same. But if we wanted to do, and then this is the best example, so we do HTML without standalone, and then we get something like this. So H1 tags, H2 tags, P, image, source, just basic straight up HTML conversion. But if we add a .s onto that, and that HTML, then also we get the doc type declaration, we get the head, the body tags, and all the things that would make up a full page. It's cool, because it has done that for you. Now, if you wanted to write your own web page and get more involved, what I've done in the past is just use this as a starting point, and then you can maybe start putting in your own stuff if you want to put in your Google Analytics flags and special fonts and stuff. This will get you pretty far, and then you can use your HTML knowledge to do the important things.
But every time you generate the HTML file, will you have to like add little bits that make it complicated stuff? Is there a way to automate that?
In Pandoc?
Yeah. Like say add this piece of HTML at the end.
Yes. Yeah. Actually, yeah. So there are other command line tools you can get into. I guess this is the time in the lesson where we should go talk about those. So -s stands for standalone, but there's other Pandoc commands you can use. One that kind of addresses your question is like -H, which is kind of like -header. That'll allow you to make sure that if you're building an HTML file, you can give it another argument, which will be like another piece of HTML preamble or something that will get inserted at the top of your Pandoc file. I'm pretty sure there's a similar argument for like a footer as well. So if you had, boilerplate like blog header HTML thing, a boilerplate footer, and you could just write those yourself, and then you could generate any number of different blog pages by pandocking something and giving -H F maybe. And of course that list of things is available with the -H command, the help command at any time. Let's see that's right. So here we go. So these are the three you might be able to do that with.
So the thing, how do you spell LaTeX? Does it matter if it's like capital L, or does it matter when you like tell you which language that it care about?
No, I don't think it matters.
Okay.
Yeah.
So mine
Actually, if you're doing something in command line, you're not going to be doing any capitals through it.
Yeah.
But okay, that brings me to another point, which is where it gets kind of complicated. So one thing that you use when you're customizing LaTeX is using like a variable command argument. So I haven't used it in the context of HTML, but in the context of LaTeX, where you're running your Pandoc through a template, there can be little variables in that template that will say, if the user has passed this variable in here with this name, then put that right there. So if you're generating a LaTeX template, there's a spot for that in the like font family set font uses package area, then you can just give that command line argument and put that in your generated text file and allow you to set your own font. So we can move on to LaTeX next, and I guess you can kind of answer those questions. Do you have any more questions about like HTML stuff before we move on? Okay, cool. Now for HTML, I think the best way to use Pandoc, without spending too much time getting too tricky, is this. Write which one in Markdown, convert it, and then maybe do some of the extra bells and whistles just on the pure HTML document. Or things like, honestly, if you're going to blog things like Jekyll, you're going to be able to do a lot of stuff for you too. Okay. All right, so we still got our little sample Markdown file here, just very basic. Maybe you want to add like another paragraph or something. And once again, that's sample.md. Now let's see if we can convert it to a text file. So sample dot. So this is basically gone through and converted, Markdown to text, which is pretty cool, but kind of far away from what we totally want to be able to actually read and publish something. So once again, we're going to go with that -s. tag.
Yeah.
The standalone, and now it'll produce a much more fully fleshed tech document. And there we go, now go up in templates. So boom, those. This little Markdown file with just a couple lines of Pandoc all of a sudden goes to this huge tech document with all of this stuff. And we can publish it to a really nice looking little PDF.
What happened to the image? Is it there?
Yeah. Oh, it's down. Where is it? Oh, there it is. It was so big it put it on the page. But look, it's got the figure caption there. That's really nice. So they took the alt text that I gave it, and then in the sample Markdown file made it like the figure caption. Very cool. So that will impress a lot of people, but of course, if you're doing tech, you kind of want to put your own spin on it, and maybe follow some kind of style guidance or something. Let's say the Department of Physiology is something for you. So there's a number of ways to get custom with this Pandoc tech production process. And I'll go over one of the most straightforward ways right now, which has to do with getting your own custom template and then using variables to set certain features within that template. Oh, and look at all these weird files that the tech has produced for us. It's one of the things I still don't understand about it. There's terminal, so we can do Pandoc, sample.md, do sample.tech, put that standalone. Now if we were to also do dash template equals my template.tech. That's the template file that I have in this working directory right here. Then it will use that to build the LaTeX file. And you can see I've got my template.tech. I basically downloaded it from a link that I put on the lesson content material. There's already like a default LaTeX template built into Pandoc, but this one I downloaded I think is a little bit more transparent and lets you control a couple more things. So if you guys are curious, that's right down, where is it? With it, sorry guys. Oh, that's it. But you can see this template is basically, it's got all the like standard boilerplate for a LaTeX file, but it's got a lot of these, like $sign expressions everywhere. And those are basically the variables. So you could get really fancy and look at all those and decide, if you knew exactly how the LaTeX document worked, exactly what you would want to change. But we can keep it simple, and based on what I got working, I'm going to keep it very simple and just use what I know. One of the most important things about a LaTeX document is the font family. So, I'm going to show you. Yeah, so actually, well, first off, let's talk about the template and command again. So dash template equals whatever name of template.tech. It will use that template to create your tech file. That template file either has to be in your working directory or in Pandoc's template files folder, which is actually something that doesn't come with the default installation. So you have to go to your home and then create like a home/Pandoc/templates folder to house all those styles. But just using these straight up isn't going to produce much of a difference. So we can say we're going to create a tech with template and a tech without template. here's what we got from the default LaTeX template, and it's up there. Oh, actually, yeah. And so this publishes this that we've seen before. Yeah, it's up there on the second page. Now we go to the template, and here it is. And it's hard to tell. It's two different. There is some more comments here about how to like scale images and stuff by setting variables. Right. Pretty much it's the same vanilla LaTeX thing. There it is on the second page. So the customization comes with declaring variables that are in the template file to change the output. So if we go to that template itself, we'll see something like this. So if font family, if that variable exists, then we'll use it, in this use package command. And just like, basic LaTeX stuff, one of the easiest ways to set a font is to do this use package, and then like the name of your font package in the beginning to set that font style for the rest of the document. So we go and we get that template argument back. Then we also do this -v to give it a variable and do font family rows. And then the tricky thing here is there's not that many basic font packages that come with like a Tech Live installation, and they all usually have like shortened names. So you kind of need like know off the top of your head or do some research on what are available. There's a lot more steps that are involved with like downloading your own LaTeX font files and getting those set up with this. So one I know is, times. So first off, it's cool that passed. If we try to do something like bear font, bear font worked too. Okay, so the errors would be thrown if we try to convert it to a PDF, because it'll produce that text file for sure, but then LaTeX will throw an error saying, hey, there's no actual bear font. So let's just go back to times. Actually, no, bear was more fun, but bear, okay. And now we'll go to that text file that it produced, which I believe was sample with template, yeah. That file. Here we go. Okay, so use package up at the top. We can see that we've got there. So that's cool. It's not going to work if we try to run it, but yeah, we'll get some error. Bear.styles not found. Makes sense. But now we can kind of control some aspects of our output text files. Now, one thing that I maybe should have mentioned earlier is you can also skip a lot of this LaTeX stuff. If you don't want to deal with it just by converting your file to a PDF straight up. And you're going to need, tech on your computer to do that, but it'll basically handle all this, compiling of tech documents for you. So let's do that with our font family there. And yeah, it's not going to work. Because the LaTeX doesn't compile, but if we were to do font family times, yes, it would work. And look, we've got this beautiful sample template.pdf. Nice. It's got a Times New Roman typeface.
And you also know how to handle the equations or whatever.
Yeah.
Like the mathematical stuff.
Okay. And if we didn't give it that that variable there, then yeah, we get a different font face. That's like the default computer modern typeface for LaTeX. And then back to times. And so that's just kind of like the most basic kernel of like doing this whole templating and variable substitution to customize the document. Going farther than that might take a little bit of trial and error and learning how LaTeX works, which is, scope of today's lesson. But I also want to kind of draw your attention, I guess we still got a bunch of time, to like kind of an easier way to do it, especially for a thesis, if you guys are interested in that. Because how I did my thesis with Pandoc was a bit different than this. So, well, first off, I should give credit to so basically, this wonderful genius, Tom Pollard, on GitHub, has put out a repository called like template for writing a PhD thesis in Markdown. And basically what it is like, a nice template for kind of handling all these like more complicated LaTeX style formatting and Pandoc things. So you can write a bunch of Markdown files, essentially one corresponding to every chapter of your thesis, and then use some of his pre-built Pandoc commands, and I'll produce something that looks pretty nice. If you're interested, I spent a lot of time doing some like custom LaTexing and custom Pandocing, and forked it with the proper typesetting for the Department of Physiology. So you can take a look at that. And it's actually, so it's been 4 months since I actually did this kind of stuff, so I'm not totally sharp on how exactly I did it, but I'll walk you guys through the basics. So basically I've got a source folder here with, 13 different files, all corresponding to different chapters of the thesis, and then a figures file with all those figures in there. I'll go into, there's also a references.bib here at the end, which is used to generate the bib text citations that go in the text. I can talk about that more if you guys are curious. That's one of the trickier parts of the project. So there's a source file, but then there's also a style folder. And this has got the important things like that template.tech that's used to generate the project. It's got a CSS styling, which I don't know exactly where that comes in. Also like a preamble.tech that is mostly, let's see, that's kind of like the preamble is super important because that kind of like grabs your table of contents and put it where it should be, and grabs your intro and puts that where it should be, and some of like ordering of the document. But so all these little style folders are here. Oh, there's also a style folder, the ref format that determines how your citations and your bibliography are ordered. But those are important for generating the actual typesetting of it. And you can use those to produce an output, produce a PDF file, just by using basically a large convoluted Pandoc command. And there's a make file that Tom Pollard has written that tries to make that easier, but I had tons of problems with that, so I just kind of stole his stuff and created a big long Pandoc file that I could copy and paste in the terminal whenever I wanted to build my thesis. And there's a lot of stuff here. Don't really need to go into it. I don't understand every part about it, but basically we're Pandocing a whole folder here. Source, every Markdown file in that folder. Our output will be a thesis.pdf file in the output folder. That header is going to be that preamble.txt that orders like a table of contents for us. Bibliography, which is going to be put at the end, is that references.bib file is in my source. And
can I ask you how you cite them inside the document, just like a regular LaTeX citation?
Yeah, I'll go into that. Well, I'll show you some of what like writing the thesis was like. So there's a bibliography, and knows what to do with bibliography. Now here's some variables, the font size that I want, paper size, the class of document, and it is number of pages. CSL style is like the citation style formatting, and there's that LaTeX engine. It has to be LaTeX, ZE LaTeX for some reason. So basically, I've got those style folders and then source folder, and boom, all this stuff, and boom, I get this PDF thesis out of that. And yeah, okay, I'll show you what the actual like source files are like. Here's it. So one important thing is I had to end up doing a lot of like custom LaTeX formatting to get things to work exactly right and it didn't look the way I wanted to, especially conforming to like the Department of Physiology's guidelines. I was able to do that just by putting like naked LaTeX commands into my Markdown files. And it didn't get rid of those, it just carried them right over to the LaTeX document, and then I compiled everything fine. So that's something to keep in mind. This one document has a ton of it because I'm like centering, styling, and page numbering and stuff. But mostly I was just writing stuff like this, and just writing it in Sublime, which was actually pretty nice. So here, it just looks like the sample Markdown files we're working with. I've got my H1, H2 titles and stuff. Some LaTeX page numbering there just to make sure it's doing it correctly. And I would just write. Sometimes I would be writing in Word, so I get the like spell checking and stuff, and I just like paste it over to Sublime. But to do a citation was the hardest thing. So I had all my citations in like Zotero, and this works for like EndNote and Mendeley and all these other ones. You can export as a BibTeX file your entire citation library. And then you'll get something like this. Just a monster document that has basically all the data for every one of your citations. This thing is so big. So big. So then all you need to do to get that citation in your document and properly formatted with like the year, however cell or nature AKA format you want, and then also add it to the bibliography section at the end of your thesis, is to put it in as a reference to the specific BibTeX entry. So here I'm writing, and I want to cite Donald Head's Organization of Memory. So I'm typing and typing. Now these kind of just like doing those like image and link Markdown files. I'll do a square bracket at tab underscore title, first word of paper, followed by the year. And that's basically a call out to this bib file where I've got the corresponding, there it is. Here's the corresponding like BibTeX entry. So there wasn't any fancy like I could pull up a link and autocomplete citation in. I knew what all these references would be, and I have them in this big gargantuan bib file. And so I type, and I basically see a plain text citation that I've just written with like auto inputs into a Word document, and then I have to manually go and search for what the BibTeX export had like named all of my entries, and then I would just put them in manually in Markdown syntax. So it was quite effortful, but a decent trade-off because, like I said, it did the proper formatting for me and also put it in my bibliography. Really nice. So there it is. You guys see that in just like the square brackets with the BibTeX callout. Oh, here I'm also doing some fancy italics around neurons that fire together, wires together. It's embarrassing. Now, images are important too, and a big part of this, like PhD Markdown thesis GitHub file is like proper formatting for doing images, making sure they're the right size, making sure that captions are in the right spot. So this is really similar to just image file. This is actually the same syntax as doing any image file in Markdown. So bang, and then the like ref text or whatever, followed by the URL to the image. The only difference here being that ref text is the caption that's displayed below the image. So I was also throwing an additional Markdown formatting to that. So I would bold the title up with double asterisks, and then I could even put those BibTeX links in at the end here with @SUSE how 2016. But once again, the format of those exports would just be the first name of the last name of the first author, and then the first word and the title and then the year. And basically just following it, yeah.
So if you're going to link to that image now, would you use a LaTeX tag or like a Markdown link? Like if you want to reference ref a figure.
Oh yeah, just Markdown. Yeah. Oh, you mean like see figure 2 or
Yeah.
something like that?
Yeah.
Gosh, well, I think I just put those in like manually.
Like LaTeX.
Yeah. Yeah.
So you can use Markdown. There's a guy who makes filters for those on GitHub. And then I think it's called EQ Moss or something. And then you can like name the figure something, like, whatever name it is. And then you can reference that name. And it will update the order of the figures. But it's a little bit like extra going around with angles custom filters, but it's not.
Cool. This is one more thing that took a lot of time that I can show you, which was the table of contents. Oh, that's okay. Not listed figures. That's what I did. So once again, linking the figures I did manually. I didn't do really anything fancy. So I also had to go and write out the name of all of my figures in plain text, and then find. Yeah, I had to do it. I had to find the page number that the final document had put them on, and then put them in like this. And there might be a fancier way to figure that out and get that done automatically, but I was in a rush and wanted to graduate, so I just yeah. And yeah, I guess I can show you the pieces to see what it looks like. And it's your typical average thesis printed in just basic LaTeX computer modern. So I didn't do any really fancy typesetting or anything like that. But it worked. Jumped in. Cool, and that's basically it. That's the extent of my knowledge regarding